Today we'll discuss about different size of globes and their related issues like length of radius, length of meridians, length of equator or their scale. All these problems we'll discuss now. There are two types of problems. One is the globe is replaced by larger one. What would be the change in areal and linear features of the globe? What would be the change in surface area of the globe? What would be the change in length of meridians or diameter or radius, whatever it be? Second problem is that the globe was replaced by smaller one, and in that cases what would be the change on the surface area of the globe in the length of meridians or parallels, or what would be the change in the radius or diameter of the globe. Finally, what would be the change in its scale. Suppose the globe, a three-dimensional object, is changed x times, and if the globe is replaced by a larger one, in that cases x is greater than 1, and if the globe is replaced by a smaller one, then the change is less than 1. Globe is three-dimensional objects like this cube, which has x, y, and z dimension. Here, all the three dimensions are represented by x. Therefore, the volume of this cube is x cube. Suppose the volume B of this cube is changed to 2.7 times. Therefore, the volume of this larger cube is 2.7 V. How the one-dimensional edge is changed? The length of the edge is x. Now it is this. So what is the length of this? This is cube root of volume. Volume of this cube is this 2.7b. The length of which is cube root. And I used 1 as power because it's one dimensional. Though it will result no difference from these. So always we have to come to one dimensional measure first, and from there we can measure area of two-dimensional object or volume of three-dimensional object, whatever we have to. Now the surface area of this plane is this. It's a two-dimensional object. Therefore, the surface area of the changed cube or enlarged cube is this. What is the surface area? It is this. First, I have changed the volume into one-dimensional measure, that is cube root of 2.7b, because its volume is 2.7b. So I came here and then I use 2. The dimension of a plane is 2 as power of this one dimension. And this way we can measure surface area. So always we have to come to one dimension from given three-dimensional object or be it two-dimensional object. Suppose here is a globe with radius this, and the radius is double. So what would be the surface area of this larger globe? or volume of this larger globe? What would be the length of meridians of this larger globe, or how the equator of this larger globe is changed? How much we have to face all these kinds of problem? If we know the scale of this globe, what would be the scale of this larger globe? We have to find out all these problems also. Suppose the diameter, sorry, suppose the radius of this small globe is 3 centimeter. Now the radius is changed two times, that is this mass. So it has been 6 centimeter radius. In that cases, what would be the change in the length of, say, equator, length of meridians, or radius, or axis, or surface area of the globe, or volume of the globe? So all these change we have to measure. What would be the change in surface area? Surface area is 4 pi square. Its equation, surface area of globe. So it is 113.04 square centimeter of smaller globe, and it is changed 2 to the power 2 times because radius is enlarged 2 times. Therefore, surface area is enlarged 2 to the power 2 times because it's two dimensional. Dimension is used as power. So 4 times, and therefore the surface area of the larger globe is 452.16 centimeters square. Now, what would be the change in the volume of larger globe? Equation of volume is 4 by 3 pi r cube, and therefore the volume of smaller globe is 113.04 cubic centimeter. Volume is changed 2 to the power 3 times, that is 8 times. Therefore, the volume of larger globe is 904.32 cubic centimeter, which is 8 times the volume of smaller one. So we have to always come to one dimension from given volume or surface area of globe, and then from one dimension we can measure two-dimensional or three-dimensional properties of globe. So if the volume is given, we have to come to one dimension by cube root of volume, and if surface area of the globe is given, then we will come to one dimension by square root of surface area. We will face different type of exercise related to globes. Suppose find the scale of the globe with radius 60 centimeters. Given Earth's radius is 6,000 kilometers. How can I measure the scale of this globe? Simply radius of globe divided by radius of Earth. This ratio is the scale of this globe. Second, there are two globes with radius 30 centimeter and 60 centimeter. Find out the ratio of their volumes. How can I solve this problem? First, from radius, find out volume of the first globe. What is the volume? Volume is 4 by 3 pi r cube. Here r is 30 centimeter. So easily we can find out volume of the first globe, and same way we will find out the volume of second globe, and then we'll come to ratio of volume of these two globes. Third question. There are two globes with radius 30 centimeter and 60 centimeter. Find out the ratio of their surface area. First, we have to come to surface area of this globe using the equation 4 pi r square, and same way we'll find out surface area of this larger globe, and then we'll find out the ratio of surface area of those two globes. Another question, there are two globes with volume V and 3V. Find out the ratio of their surface area. Ratio of their volume is simply 1 is to 3, but what about the ratio of surface area? From volume, we'll calculate surface area. First, we'll find out the radius of this globe, and then using that radius, we'll find out surface area of first globe. Same way, we'll find out surface area of this second globe, and finally, we'll find out the ratio of surface area of these two globes. Again, two globes with volume V and 3V. Find out the ratio of length of their meridians. First, we have to know the radius of first globe using its volume, and in this case, we'll use the formula 4 by 3 pi r cube is equal to V. Therefore, we'll get the value of R, and using this R, we'll find out the length of meridians. Length of meridians is pi r, and same way we'll find out the length of meridians of larger globe, and finally we'll find out their ratio. Another question, there are two globes with volume same V and 3V. The length of a river was 11 centimeter on first globe. What would be the length of that river on second globe? So first we'll find out radius of first globe and radius of second globe, and from there we'll get a ratio, and using that ratio we'll calculate the length of the river on second globe. How? If the length of the river on first globe is 11 centimeter, so using that ratio of radius, we'll easily can calculate the length of river on the second globe. The seventh question, there are two globes with surface area E and 4A. Find out the ratio of lengths of their meridians. Surface area ratio is 1 is to 4, but what is the ratio of length of meridian? First, from surface area, we have to go to radius of the first globe, because radius is one-dimensional and the length of meridian is also one-dimensional. So, first come to radius of first globe, and same way come to the radius of second globe, and using this ratio of radius we can measure the ratio of length of meridians. Now same two globes with surface area A and 4A. Find out the ratio of their volumes. First we have to come to radius, and from radius we'll go to its volume, and same way we'll find out the volume of larger globe, and finally we'll calculate the ratio volume of these two globes. And finally, there are two gloves with surface area same A and 4A. The length of a meridian was 11 centimeter in first globe. What would be the length of meridian in second globe? Here volume was given and here surface area is given, otherwise problem is same. So let us try to solve all these problems. I therefore request you always ask yourself, your teacher, what, where, when, how, and why. And don't stop until you are satisfied.